In this problem, we're given a drawing of 4 different resistors. Um, we have 2 here that are in series, and we have 3 that are in parallel. We can combine these 2 into a single one and then add them up. So the 2 equations we're going to be using here are for resistors in series, the equivalent resistance, which is just the total resistance. We can simply add up all of our resistances. But if we have them in parallel, which we do have a few, the equivalent resistance will actually have to add the inverses of each of them. And then we'll actually take the inverse of that sum whenever we get it. So these are the 2 equations we'll want to use. Okay. So first, we'll start off by combining these 2 resistors here. And we can simply do that by taking R plus R, which is 2R. So we can simply replace these resistances with a single resistor of 2R. Okay? And we did that just by using this equation here. Okay? So now that we have 3 resistors in parallel, we can use this equation. Okay? So our equivalent will be 1 over, well, first R, that's this one here, plus 1 over 2R, that's this one here, plus 1 over R, that's this one here. Okay, and then we'll take the inverse of all of them. Now, if you notice, we can combine this one and this one, and we do that by, it'll basically just be double. So 1R plus 1R is just 2R, but since it's 1 over R plus 1 over R, we get 2 over R. Okay, and then we'll bring this down. Okay, 2R. And then to add these 2 terms together, what we'll do is get the denominators equal to one another. And we can do that by just multiplying the top and the bottom of this one by 2. So we get 4 on top, 2R on the bottom, plus 2R over 1. Okay. Okay. Then we can add the numerators and we'll get the same denominator. Okay. 4 plus 1 is 5. Okay. And then to inverse it, what we'll do is we'll just flip the numerator and denominator. So 2R over 5. And that's as simplified as it gets, so that is our equivalent. And that's our answer.